than it is. So after 7.8 here, we want to be able to look at these radical terms and being able to distinguish when do we use the I symbol as part of answer versus not using I at all. Okay. Um, so the title is complex numbers. And we start by looking at this equation, x squared minus 1. Um, so if we were to solve this equation, and if we look at this here and we want to find, okay, what value of x such that when we square to get -1, well, there's no such thing in the real number system, right? In the real number system, we can't find a number that when we square it, we get -1, because when you square any numbers, if the number is positive, the square of that is going to be positive. If the number is negative, the square of that is still going to be positive. If you think about -1, well, -1 squared is going to be +1. So there's no such number when we square to get -1. So what happened to this type of equation is mathematicians decide, okay, well, what if we go further and isolate the x using the square root? So we can say, okay, well, what if I want to go further? I want to square root both sides, and I get this here. Well, square root of -1, we don't know what that is. So we define what this number is. So this is not a real number. So we define what this is. So we say, okay, well, we don't know what this is in real number. So let's go ahead and define this as, square of -1. Let's call that a letter. Let's call that some number that we don't know. Let's call that I. I stand for imaginary numbers. So from that definition, right, so I is square root -1. Well, since I is the solution for this equation, since I is the solution for that equation, the square of that should equal to 1, because, excuse me, -1, because it's a solution to this equation, right? So if this square of -1 is a solution to x squared equal to -1, then the square of that must equal to -1. So we have these two definitions starting out. Okay. Again, we don't know what square root of -1 is. We just give it a name. And since we already named the number system that we work with is real number, so we just call this new number here as imaginary, kind of clever. And then now we're saying that, okay, what if I want to I want to combine this weird number here with something that we already know? What would that create? Well, if we do that, we create the complex numbers, meaning we take the real number and then we just kind of joint that with this weird number I, imaginary number. So that create a complex set, meaning all the numbers in the new set here contain the real number part and the imaginary part of I. So that allows us to have a larger complex, larger numeracy system to work with. And then now we can simplify something like this, like this, like this, using this new set of numbers called complex number. But let's go back to the definition here. So if we have these two definitions, I is square root -1, therefore I squared equal to -3, -1. From there, we can even apply the property of exponent. We can even do this, and maybe take the I to 30th power. Right? We can actually apply the exponent on the I itself. Okay. So we say that, all right, well, I to the third, we can look at this and say, well, that's I squared times I, right? Because I squared times I is going to be I to the third, because 2 plus 1 is going to be 3 in the power. Well, we know I squared, based on the definition here, is -1. So I to the third, same thing as -1 times I, that becomes -I. Okay. Then I to the 4, using similar I squared, we can say that's I squared times I squared, because probability of exponent, just add the power. Well, I squared is -1, so therefore we have -1 times -1, and that becomes 1. So from these four result of powers of I, it becomes a pattern. So we can, from these four here, we can actually simplify any powers of I, um, and make sense of it. What happened here? Can't zoom out. Second. I don't know why I'm not allowing me to zoom out, zoom in here. Let's exit that out. Try this again. Okay, much better. There you go. All right, we'll come back to the simplifying the power i's in exercise 3 here. But let's just go back to this radical step that we didn't have an answer before this lesson, and that was, we just kind of write not a real number in the early section of chapter 7. So now we can actually simplify something like this here. The answer is it's not gonna be a real number. The answer is gonna be contain the I, because it's square root. So what we can do here is we can actually rewrite this as -1 times 25. And then from there, we can say that, let's go ahead and take out the square root of -1. Okay. And then now, knowing what the square root of -1 is, the way we define it, we just name that letter I. This now become phi I, because square root of 25 is phi, and then 5 times I is phi I. So before we said it's not a real number, in this section, we say that non-real number is an imaginary number of phi I. If we square this, we get a -25. Let's check that really quick. Okay, so if we square this, we get phi I times phi I. So that's 25 times I squared. I squared is -1, so therefore you get -25. So that's how we simplify square root of negative radical now. Any questions so far there, guys? So for a problem like this here, you gotta simplify inside the radical first before you apply the negative. So you want to do -1 times 75, -1 there, and then you apply the you simplify this part first. So that just become square root of -1 times square root of 75, and then square root of 75, you can do that on the side. So that's 25 times 3, so that's 5 root 3. So now we have, this is I, so that's just negative I, because it's -1 there, times 5 root 3. So now that becomes -phi I root 3. Okay. For the FOIL part, multiplications, radical, is very similar to the previous sections. All you do now is just with the extra letter I, and you also have rationalizing denominator as well. I am going to do one problem like this with you guys here, so that way you know how to do this, and then we can stop there in case you guys have other questions. Actually, let's do both of this. I to the 60th power, we want to figure out what this power of I becomes. So using this result up here, this 4 different powers I, we have these 4 results. what we can do here is we can say, all right, well, 60th power. We know that I to the 4th is 1. So one method is rewrite this 60th power in multiple of 4. Okay. So how many times 4 go into 60? How many times 4 go into 60? 15 times, right? So we can say 60 is 4 times 15. You guys agree there? Rewrite this using exponent properties. We can say this has become I to the 4th raised to the 15th power. Okay. And then we say that I to the 4th is 1 because we did that up here. Okay. So we have 1 raised to the 15th power, that's going to be 1. So if we take 60th of power of I, the answer is going to be 1. Now, if you don't like that way, there's another way of doing this as well. Okay. And I think some of us already done this in the homework based on the book. The book does it where instead of rewriting 60th or any power of I in terms of multiple 4, we are gonna go off by power of 2 for I. Okay. So how many times 2 go into 60? 2 go into 60 30th time, 30 times. And then we can rewrite this as I squared to the 30th. But we know what I squared is. That's become -1. So we have -1 raised to the 30th power. So imagine taking -1 time itself 30 times. So there's going to be even numbers of negative sign, meaning you're going to have this here. Right, time itself, 30th time. So that's going to be a +1, right? So the same answer there. So either way it will work. You can either break the power in multiple 4 or multiple 2, and you have to simplify that result at the end. Sometimes it's not always equal to 1, sometimes it's equal to something else. Okay. All right. We can try part B here. I'll let you guys try part B on your own there.